Alright, in this problem I'm going to demonstrate the equivalent annual rate calculation, or the effective rate. This goes by a bunch of different names that you see out in the real world. Effective yield is the one I see most often in the business press, or in things like bankrate.com calculations. So effective yield, effective annual yield, equivalent annual rate, equivalent annual yield. It goes by a bunch of different names, but let's demonstrate first. Let's say, if you had deposited $1,000, took $1,000 out of your pocket, and you were getting 10% per year, compounded once a year, then how much would you have at the end of the period? And we could do this one in our head, because 10% of 1,000 is $100. So you'd have $1,100, but I want to go ahead and calculate this to show that if you compound more often than once per year, you'll have more than $1,100. So if we take the rate, number of periods, payment's going to be 0 because you're just going to put $1,000 into the bank, then you'll end up with $1,100. Alright, so with the rest of these, the difference here, if it's quarterly, there'll be 4 periods, and it'd be 10% divided by 4, or 2.5% each quarter. And you'll actually have more than $1,100. That's because you'll start earning interest 90 days from now. You'll earn interest on the interest, and then 180 days you'll earn interest again. So the faster you start compounding, the faster you're actually going to earn the money. If it's monthly, you're going to get 1/12 of 10%, and you're going to actually end up with still more money, $1,104. If it's daily, that's $365, and that'd be 10% divided by 365. That'd be your daily interest rate, and you'll end up with more money still. So even though all of these are a 10% nominal annual rate, the faster it compounds, the more interest you're going to earn. For instance, on daily compounding, you're going to have more money tomorrow than you put in today. That's because you're going to have your original $1,000 plus 1 day's worth of interest, and that day's worth of interest starts earning interest on the interest tomorrow. So that's why you end up with more. That's called the magic of compounding. There's actually a formula for this built into Excel. It's called the effect function for effective rate. EFFECT, and then open parens. Calculators build this in as well. In Excel, you want a nominal rate, whatever the nominal rate is, and then the number of periods per year. Now, if it's 1 period per year, then the nominal rate and the effective rate are both going to be the same number. Alright? But if it compounds more than once a year, it means that you have a higher equivalent annual rate. Now, all of these went 1 year. If you took what you ended up with divided by what you started with minus 1, that would be the equivalent annual interest that you would earn over the course of the year. Okay? So if you ended up with $103.81 more than you put in, your rate is going to be 10.38. If you ended up with $1,104, 1,000 of it is the money you put in, 104.71 of it is interest, then the interest rate would be 10.47. Okay? So if I do this over a 1-year period, the equivalent annual rate just says what's the equivalent rate if you only got paid interest once per year. Makes it easier to compare things. Now, here we are comparing nominal rate of 10% in each instance. Where it starts to get more difficult is when you're trying to compare different rates. Let's say this one is 10%, but this one's 9.95%. Lower nominal rate, but it still ends up being a higher effective rate. Let me add some decimal places down here. And let's say this one's 9.75%. 9.75% compounded monthly. You still end up more. Well, what if this one's 9.5%? See, that would be less. So just because it compounds more times per year doesn't necessarily make it better. All right, and if you had to choose between any of these four, if it was an investment, this one would actually yield you the highest rate of return. Saying, oh, well, that's not much of a difference. Well, it's more difference than zero, isn't it?